Thank you very much, and good afternoon, everyone. Welcome to live from Glasgow, Strathclyde University. So this session is on, as we just heard, on integrated climate resilience. So we're going to really dig into, firstly, some of the sort of overview of what's the state of integrating climate resilience into infrastructure investments around the world. We're going to talk about some of the analytics, so the new work on advancing understanding of risks of supply chains and across infrastructure systems. And then finally, we'll be deep diving into some case studies. So we'll have 6 presentations. What I'm going to try to do is break it up into twos. So we'll have 2 presentations and then some time for questions. And just to remind you, please do ask questions on the Slido. If no one asks questions, I will be asking you questions, so I'll warn you now. Great, so I think we can get started then with our first speaker, and I'm absolutely delighted to introduce Vivien Foster from the World Bank.
Hello, Nicola, can you hear me?
I can. Hello, Vivian. Please go ahead.
Thank you. Well, it's a pleasure to be today, and I appreciate the opportunity to participate in the conference. I think my role here is really to articulate on-site perspective for climate modeling tools and related sets. What I'm going to be doing is giving you a very sense of what the World Bank is doing in this space, but more importantly, articulate some of the gaps and just with regard to relevant modeling tools to inform decarbonisation and climate change, particularly in the developing country context. Nicola, I'm getting quite a lot of echo. I hope it's not affecting you.
So we can just about hear you. I don't know if there's a way we can. So it's apparently the internet connection. So maybe just speak a little bit slowly, and I think we can just about hear you. Sorry about that.
So I'll start first with what the World Bank is doing in space. In 2021, we released our second climate action plan covering the next 5 years, which marks a paradigm shift from investing in green projects to greening entire economies. I think there are 2 aspects of this plan. The first is a big step on climate finance. The World Bank Group is already the world's largest financier of climate action in developing countries, applying $26 billion in 2021. That accounts for half of multilateral climate finance, and over 2/3 of that is adaptation. We've been at 35% target of finance for climate on average over the next 5 years, up from a baseline of 20%. And at least half of that is to support adaptation. The urgent priority is to support a small group of high emitters need to move through the transition process. And this is a lot of issues in terms of decommissioning coal-fired plants and and providing support for a just transition. So we're not only supporting the greening of it, but also helping communities that are shouldering the burden of the transition away from fossil fuels. In the poorest countries, our areas, we'll be focusing particularly since these account for less than 1/10 of global emissions, we'll be focusing on investments in clean energy at scale to avoid locking in polluting infrastructure, still achieving energy access goals. And adaptation remains relevant to all of our clients. The second, beyond the financing, the second act of the Climate Change Action Plan I wanted to highlight is the major push on developing customized country approaches to engaging on climate and development. We're rolling out a major program of new country climate and reports, which will become a core diagnostic and inform engagements with clients in the future. We'll lay out blueprints for individual countries to deliver their climate and development objectives together, helping to identify and prioritize investments in each case. And they're grounded in the paradigm of green, resilient development, and based on the recognition that the economy is embedded in the biosphere and subject to physical limits. These country climate and development reports will combine a macroeconomic lens on climate with a detailed look at the 5 key sectoral systems that need to be transformed, including energy, transport, agriculture, cities, and manufacturing, together accounting for 90% of global greenhouse gas emissions. And we intend to make these to inform activities across the donor space. The country and climate diagnostic reports contemplate resilience and adaptation allied mitigation. And of course, this is an increasing focus of our development engagement, both in terms of supporting countries to develop risk-informed decision-making and planning, developing risk information systems to inform all planning decisions, but also designing risk reduction measures for areas and assets at high risk, high exposure to climate risk, including assets, redesigning and accommodating and managing the risks, but also a heightened emphasis on maintenance, which is one of the key ways to ensure the resilience of infrastructure assets. Let me turn now to the second of my remarks, which is really a reflection, given this increasing focus on country-level climate diagnostics. What are the some of the gaps and challenges that we've found as we've tried to apply modeling techniques to address these questions? And I have, I think, 4 points I'd like to make here. The first one is that I think on the modeling of the energy sector decarbonization tests, we're relatively advanced. We have good tools available to model least cost power system expansion, particularly generation, and these are quite helpful in supporting transition paths to net zero. Perhaps 2 areas of possible further refinement would be in the incorporation of battery storage services and also the better integrated trade-offs between centralized investments and decentralized solutions that use the grid or indeed the prosumers or the decent producers of energy, as well as the demand side, integrating these better with the supply in the models. Secondly, I really want to underscore the fact that in the transport sector, I think we are far behind in our ability to model the decarbonization process. We do not have such tools currently available. Now, one aspect of this, of course, is integrating electric mobility into existing power models, which is perhaps the lower hanging fruit. We can in particular improve our ability to capture the demand from electric mobility and the shifting load profiles into our analysis of the power sector. But also not just the implications for generation planning, but what does electric mobility do to the need for transmission and distribution infrastructure reinforcement? So these are sort of the first area of integration between energy and transport. However, what we find is in the developing world, there's actually more to transport decarbonization than electric mobility, particularly because the transport sector seems to present a lot greater complexity from a modeling perspective than the power sector. On the supply, we're faced with multiple alternative modes and service providers, each of which have to be considered, providing services often that are suitable or complementary. We also have on the demand side a very strong behavioral component with myriad individual decision makers, independently taking decisions about transportation choices, which need to be influenced and shaped through policy. We're also faced with serious distortions in both absolute and relative prices, lack of road pricing, complex externalities, fuel subsidies and electricity. All of these complicate consumer choices between different transportation options and present significant barriers to decarbonization. We also have complex interactions between transport demand and spatial development, with strong interactions in a general equilibrium sense, such that transport investments and land and housing prices and markets are interacting in complex ways. In addition to those challenges of transport sector, which I think would apply to any country, I think the developing world poses additional complications because the baseline transport system is suboptimal in a number of ways, including a very high degree of informality, both in transport and in freight transportation, which complicates the design of policy measures to support decarbonization. We have a lot of pent-up demand, a lot of people who simply don't have access to mobility at all. We have a preponderance of second-hand, highly inefficient vehicles, and we have suboptimal public transportation systems and infrastructure bottlenecks. all of these aspects present opportunities for decarbonisation that go beyond the electric mobility angle and need to be considered in devising a holistic transport decarbonisation strategy for developing countries. My third point on needs is the issue of resilient adaptation. I think we are more advanced in modeling mitigation process, the decarbonisation process, than we are in modeling resilience and risk aspect. As regards infrastructure, it's particularly important to understand the system resilience, the ability to network, look for how to build in redundancies and improve resilience at the network level, but also the question of asset resilience, how to identify hotspots and design assets in ways that make them less vulnerable. Our report on lifelines that came out a couple of years ago contains a lot of interesting insights on the issue of investments in infrastructure resilience, in the relatively low incremental costs of this, given that it can be targeted at sort of certain high risk aspects of the network. The very, very high benefits, benefit cost ratios of a 4 for investing in infrastructure resilience. But the basic problem that less than 10% of those benefits are captured by the asset owner who makes the investment. Most of those are positive externalities by avoiding disruptions to society as a whole. And this, asset externalities leads to serious under incentives to invest in resilient infrastructure. Finally, the fourth area of challenges that we see in modeling tools for decarbonisation of infrastructure is the integration of top-down and bottom-up models. We are adopting a macroeconomic lens on climate change, but at the same time, we're focusing on sector-level modeling tools in these key sectors such as transport and energy. And the question is, how do we get these two things to be cohesive and interactive? One approach is to improve the macro models by zooming in on infrastructure sectors and improving the characterization. However, this is quite limited in terms of what can be done. The other approach is to try and wire together the macro and micro models so that they can be easily used. And this also presents challenges of its own. We do have evidence that if we only use macro approaches, estimate the cost of adjustment at the sector level, we tend to overestimate the costs because the macro models typically consider price as the main channel of it, whereas the sector models can pick up regulatory and technological fix that may be more cost effective. So let me stop there. But I think the main message is some refinement models, major need to improve transport sector decarbonisation modelling that goes beyond electric mobility, the importance of resilience as well as mitigation, and this challenge of integrating top-down and bottom-up approaches. Thank you so much.
Thank you so much, Vivian, and we heard that very well in the end. So thank you for sticking with us as well, despite the communications challenges. So we're going to come back to you with some questions in a minute, Vivian, if we may, but I'm going to go now to Andrew Quinn at Birmingham to give his presentation.
Thank you very much, Andrew. Nicola. Hello, can you hear me?
Yes, yeah, we can hear you.
Excellent, thank you. And thank you for that introduction. So I'd like to talk to you about supporting adaptation for transport resilience in Africa and South Asia, which is a small project that we are doing here at Birmingham in conjunction with colleagues at TRL as part of the HVT program. So our aim is to assist transport providers in low-income countries by increasing the resilience of various types of transport infrastructure to the impacts of climate change, which of course sounds like a relatively straightforward activity until one begins to think about the complexities associated with it. So we have open questions around the changing weather patterns due to climate change, and the knock-on effect of that is the need for monitoring of weather conditions and climate data over a longer period in these localities. And then, of course, we have changing design, specification, and technology, which can be brought to bear to these issues, as well as the changing pattern of scale and cost of the transport disruption associated with weather in these different areas. And with that, we need to bring in an understanding of the vulnerability of the infrastructure, which of course has a wide range of different lifespans. Some of it is legacy infrastructure, some of it is very new infrastructure, but built to different standards at different times. And then, of course, we have to consider the capacity of the local support for the different infrastructures within country. And so this rapidly becomes an extremely complex and wicked problem. We are approximately a 6-month project, and what we have done to date is put together a state of knowledge report, which I'd like to tell you a little bit about. And we've been presenting this at a number of workshops and today here at COP. And we will take away the feedback that we receive from these workshops and this report and put together a policy guide and research article on our findings across the subject. So what we have been doing in order to put together this state of knowledge is reviewing national adaptation plans. So we've been analysing 18 NAPs and NAPAs from low-income countries and low and middle-income countries across Africa and South Asia. And we've been using a multi-criteria analysis based on the new ISO 14090 standard. And the conclusion that we have drawn is that these adaptation plans are developing and improving over time. However, when we begin to look at transport as a specific sector, we see that not all of the NAPs and NAPAs are addressing transport directly. Some of them are only addressing it indirectly in terms of its impact on things like agriculture. So we also notice that a lot of the current analysis focuses on the national or sometimes the regional vulnerability. And that is very good, but the lack of local analysis and the lack of local support for that analysis does lead to problems with being able to make local decisions and detailed planning for improving resilience in specific cases across the country. So we need to move from looking at mean values into looking at extreme values. We need to move from the national and the regional to looking at the local. And within our analysis, we also find that we need to encourage and support looking at implementation and looking at evaluation, monitoring of infrastructure resilience performance. However, the situation is evolving rapidly, and on this slide you can see how the distribution of NAPs and NAPAs has developed over time, and we're beginning to see an increasing number of more detailed analyses, and that is growing over time, and that is the move that we need to support with additional tools, signposting and data. We've also been reviewing the tools that are available to low and middle income countries, and we've reviewed 35 tools, again using a multi-criteria analysis, which focuses on the idea that these tools need to be appropriate for the right user at the right time, effectively. And the good tools in the analysis are really ones that focus on part of the process. So they have the capacity to look in detail at a particular element of the process. So there are good tools looking at the design of the NAP. There are good tools around assessing vulnerability in individual cases. But what we find is that there is an important difficulty for practitioners in navigating the whole of the complexity of the process from beginning to end, how to pick out individual tools and particularly how to link them together in ways which deliver the kind of holistic view that they need. So that is a particular challenge, and a particular challenge for the capacity as well. As part of the project, we've also been interviewing stakeholders in country, and we found that there are a great deal of focus on particular impacts that are seen in countries in these regions, a particular focus on flood impacts, which of course is something that is being experienced more frequently, and a particular focus on weather impacts, extreme weather impacts, rather than perhaps a broader climate awareness. Now, obviously, that has impacts in terms of designing for resilience and thinking about the future impacts and the future stresses that will be on this infrastructure. We've noticed that design specifications are often important in the process of building new infrastructure, but these are seldom related to future climate. And therefore, we need to do some work around building that climate awareness. We also found that there is a particular gap in monitoring, and I mentioned that at the beginning of my talk, and that is something where the changing climate and the changing weather patterns really does mean that we need to build up this monitoring capability. We need to build up links between different organizations and within organizations in order to assist with this problem of capacity building and deal with the issues of data. So there are many, many good sources of data, but many of them are being accessed on a very informal basis and being accessed for different parts of the process in different ways. And so again, this viewpoint of a holistic drawing together of many different stakeholders we think is very important. So overall, through all of that analysis, what we've done is tried to draw together some key issues that we think need to be reflected in the policy guidance that we'll be drawing up. Parts of this are to do with government coordination, so moving from the national and the regional down to the local and drawing in local stakeholders from different modes, different interest groups in order to be able to build resilience in a holistic way. Building that capacity and the awareness of climate over and above the awareness of extreme weather, and bringing together different sources of data. And within all of this, of course, there is the need, the desire to bring together local communities and the private sector as well as the public sector in drawing up these kind of resilience plans so that there is a holistic plan that is able to be facilitated. So I'd like to thank you very much for your attention. I believe hopefully there are some leaflets in the room around our project, and if not, then please pick up a leaflet from the website, and you have our link details there. And we would love your feedback and your assistance in drawing together a policy guide that really can help and support in these different areas. So thank you very much, Nicola.
Thank you very much. Thank you, Andrew. And to let you know, I was in the blue zone earlier, and your leaflets are plastered over every resilience stand in the blue zone at COP. So your team has successfully infiltrated COP. Okay, let me
hear it. Thank you.
Let me come to a few questions there. So we've had some questions from the audience. I might take my prerogative as chair as well, maybe to put a question first to Vivian, but perhaps Andrew, you'd like to add in as well. So Andrew, you'd mentioned the sort of 35 tools, and I was just interested to hear from Vivian about how, when your teams are working in country, Vivian, which from my own experience at the World Bank, I know is can be a very intensive experience. How do the teams find the right tools to use? So how can researchers like we have online here actually develop useful tools that can really feed into operations of the World Bank and other development banks and investors more broadly?
Well, thanks, Nicola. I think it's a mixture of things. We do have some tools, internal tools of our own that we've developed. This is particularly true in the case of energy. So we have our own in-house model, and we have a lot of developing country power systems, modeled and so on, available off the shelf. In other areas, we rely on contractors. Increasingly, we are very keen to academia and really stay at the forefront. This is a fast-moving area, so that's why it's very interesting to be part of a conversation and to see what's coming out of the universities and how we can maybe take up new approaches in real time.
Thank you, Vivian. And maybe I'll come while we still have you to one of the questions from the audience, which again is sort of one of my favorite topics, so I'm going to have to go for this one. So when we're looking at adaptation planning, how do we bring in the sort of, if we bring in the economic and financial side more strongly into decision making, particularly of governments, does that help to gain traction? And I think this comes to your point on the top-down versus bottom-up models as well, and being able to demonstrate the more macro level impact of shocks. What role do you see that playing?
So on the top-down, bottom-up?
Yes, so understanding those sorts of wider impacts.
I think it's important. I think it marks this shift from a very kind of, sectoral, case by case, project by project view of climate. This is more of a, key force that's shaping the whole development trajectories, right? And hence the need to look at from a macroeconomic perspective, the extent to which macroeconomic influence will be there. In order for some countries, it's really existential. They're maybe a very big part of their economy or their fiscal resources and fossil fuels, and they're very kind of profound need to reconsider the development path. In other countries, it may be more of a headwind, that certain things more challenging or more expensive. So I think that macro perspective is important, but at the same time, you need that more look at the real nuts and bolts of the sector level, because most of 60-70% of emissions are coming from transport and energy. So macroeconomically, we need to figure out in each country what it would take to decarbonize those particular sectors, and hence I think the need to keep both of those perspectives in balance.
Thank you. And maybe let's come across to you, Andrew, with another question. There's one around sort of how do we declutter the information for decision making, and particularly given there are so many tools around, how do we ensure that there is I might change this slightly. So the question is, how do we ensure the necessary analytical complexity to allow fast adoption of state-of-the-art advances in the toolkit? I might add on, how do we also avoid unnecessary complexity as well, and something that's fit for purpose? But is there anything in the work that you've done that speaks to that sort of making things fit for purpose, but also leveraging the state-of-the-art in this area?
Yes, thank you. It is a complex landscape, and there is a sense in which it needs to be a complex landscape. I mean, the criteria that we used were the saliency, the credibility, the legitimacy, and how the model produces something which is fit for what it's aimed at. So I think there is an importance of making sure that the user group that it's aimed at is very clear, and how it fits into the holistic process. So I think, just as Vivian was talking about top down, bottom up in terms of decarbonisation, I think there is also an equivalence with adaptation and looking at resilience. So there is a certain amount and a certain number of tools that you can use at a national level that are very fit and kind of level. It's where we begin to drill down in order to make specific decisions about how to improve the resilience of infrastructure at a local level, because in a sense all infrastructure is local. It sits in a particular location, and therefore the tool set around those kind of decisions is different and has a complexity and a data requirement which is different from the national level. So I think signposting what the tool is designed to do, what its data requirements are, and what the capacity is needed in order to be able to run it. I think these are key things which would help people to pick the right tools at the right time.
Thank you. Then maybe I can put a final question to you both. So we have a question around open tools, and a specific question to you, Vivian, about I think it refers to your CCDRs and whether those will be open, and whether people in country, local people, will be able to use them themselves and build upon them. And maybe you can comment on that, and then maybe Andrew, afterwards you can come in on what role do you see for sort of open tools versus other types of tools. But Vivian, to you first.
Thanks very much, Nicola. Yeah, country climate and development reports will be in the public domain because we hope that the analytics will help to inform many different stakeholders in this climate and development debate. And in general, the World Bank has very much a policy of open access to data and tools and so on. I just wanted to underscore in terms of this point, one of the things that makes things fit for purpose, and it's to do with city. I think one of the generic problems we face in the developing world, and particularly in infra, is a real shortage of data. And I think models that are too data hungry, may, however good they are, may be difficult to apply, or at least it needs equivalent effort to populate key parameters in addition to actually developing the tools themselves. Thank you.
Yeah, I totally agree that there is an appropriate level of data, but I think that also we need to assist and support the appropriate monitoring because the situation is not always static, and often we design things on a set of data which is rapidly out of date. So I'm a great fan of open tools and open data. You might expect that being an academic, but nonetheless, I think that what we can do, though, is we can help to feed the models with data and run models for people, make them available. It doesn't necessarily mean that the whole complexity needs to be open and visible to the end user who just wants to be able to run the model and develop the solutions from that. So I think there are elements that we can, whilst making the whole thing open to scrutiny, there are also elements that we can help the user not to see at different times.
Thank you very much. And I think that's a perfect point actually to go over to our next speaker, Raghav, to talk about your analytics and tools and how fit for purpose and open they are. Yeah,
thanks a lot. Could not have been a better setup. So I do have a set of presentation slides, and yeah, there they are. So I'm going to talk about open source tools and learning materials that we are developing to enrich this space of infrastructure resilience modeling. And it is a talk totally focused on development of data analytics. So what I'm covering is this whole idea about how we take open source information, or even kind of information that is enriched from within country consultations, and kind of give out interesting risk and resilience analytics. So the map that you see in this slide on the left, the one in blue, shows the exposure of roads to 1 in 1,000 year floods in Northern Africa. And if you so that is giving you the local perspective in a particular kind of area of Northern Africa. And then you can zoom out to the whole continent of Africa, and you can kind of get a sense of locations of, as Vivian and Andrew both refer to, hotspots of kind of these exposures to extreme floods. And this is the kind of capacity that open tools have already started having in terms of kind of showing where vulnerabilities and risks can be pointed out, can be concentrated. And if you kind of develop these models further, there's another level of kind of layered information that you can add in terms of then understanding how we can quantify direct damages and wider economic impacts, the thing that Vivian was talking about, bridging the micro and the macro scales together. And the whole idea of all of this kind of informatics is to then inform stakeholders with some data in terms of like where resilience interventions could be made in terms of at the local scale or at the national scale or even continental scales, so that they can reduce vulnerabilities to these infrastructures, and also how you can prioritize your investments. So there's a lot of work that we have done and we are doing and keep modeling, developing all these models and tools. And I'm giving a snapshot of a project we did with the World Bank in Argentina, where you see the first kind of bit of a web-based platform snapshot on the left, which kind of conveys the same information of like zooming in into a country's transport network and identifying locations which are exposed to different levels of floods. And also kind of, you see in that map, lots of red colors with different thicknesses, of which shows the importance of these linkages in terms of how important they are in facilitating transport in the country. In this case, both passenger transport and freight transport. And you can kind of zoom in and zoom out of this whole kind of interactive interface. So the graphic map on the right shows us clicking a road, and on that road you can get all the diagnostics of what is the kind of freight flows or the kind of traffic flows through the road, and what is the kind of exposure that under different hazards that this is subjected to, and how much of it is exposed under different kind of levels of floods. So this kind of analytics, as I said, enriches our understanding in risk and vulnerability. And this information has also been enriched by having collaborations and consultations and data from government stakeholders and buy-ins within the country, in this case from the Ministry of Transport in Argentina, who have helped us kind of add open source information and also add kind of country-specific expertise. So there are capabilities and tools that we're already developing that can inform that. Taking it further to the domain of kind of completely kind of open source information, another kind of web-based interactive tool that we've built in Southeast Asia, completely with open source information from sources like OpenStreetMap and open source hazard maps. So that the thing that the slide, the picture that you see in completely orange and blue, I understand it's a bit too vivid to the eyes, but what it shows is exposure of cyclones and floods to electricity networks in Southeast Asia. And from this, what you can kind of get is which electricity lines are exposed, and we have also kind of got information on costs, damage costs of those electricity lines, and also associated economic activity with them. And so the metrics that I was talking about, direct damages and wider economic impacts, this is kind of distilled down into this one kind of picture. I'm not going to go into detail how we exactly go into those models, but the idea is that for easy understanding of information, that is what people are looking for. What they want to know is what is the economic impact associated with an asset as it's kind of due to its physical exposure to climate risks, and also due to its importance in the wider economy. And you can kind of create this information at the asset scale, and then I also have kind of a more zoomed out, aggregated scale understanding of this in the Southeast Asia region, where you can click on, for example, an administrative boundary or administrative region and extract its loss probability curve. This is what the graphs are showing. The x-axis, I know that it's not very clearly visible, but it's mainly showing the probability of an extreme hazard event versus on the y-axis the losses that are associated with it. Moving on further, how this all information can be used in terms of investment decisions. And this is some work that we have done in Vietnam with the World Bank again, where we've kind of gone and kind of developed these risk metrics. And the value of this is then to inform stakeholders in terms of the scales of climate resilient investments that might be needed. And using this kind of information, as Vivian was talking about cost benefit analysis, its value is kind of shown over here in terms of like looking at the long-term adaptation investments that might be required in different roads in Vietnam, and then looking at the benefits, which is in terms of avoided risks, and doing this cost-benefit analysis. And as you see, there's a lot of kind of, in this picture, if you can see, the values are not one, but they're over a whole range. So we are also capturing a lot of uncertainties, because of course we're dealing here with open source models and tools, so there's a lot of uncertainty in our evaluations. And our aim is that this kind of informs the dialogue and kind of gives an understanding of what is the range of impacts that might be associated in the range of investments. And quickly coming into kind of how this is being already used and in policy making. So in Vietnam, the work that we did was used to give a high-level assessment of climate impacts and investments into climate adaptation that would feed into the nationally determined contributions that the Ministry of Transport wanted to kind of put the case forward to the government. In Argentina, we also published a report, which is the report in the middle, which talks about analytical tools, which is being used by the Ministry of Transport. Just to give a shout out of another project that we're doing at present, how this will kind of help further along the similar lines decision making in East Africa on transport and energy risks that we are looking at. And yeah, all of this kind of is very useful information that is furthering the dialogue in decision making and policy making, and we hope that kind of that's the hope, that all these open source data and models are becoming more and more prevalent in producing these kind of national scale and local scale analysis. And just kind of the last plug-in I kind of want to give out to this kind of an effort on capacity building, because we are doing a lot of models, and what I've shown you very quickly has a lot of complexity built into it. And I'm sure kind of it was, before you got your head around one map, I pretty much changed the slide probably. So there's a lot of kind of, people want to know how exactly is all this being done. So with the CCG program, we have kind of developed course material to train and provide capacity building on this whole subject of climate resilience modeling. And there's an open source course with the Open University that is available to anybody to sign up. And yeah, more than kind of, you can go and check out these links, and hopefully whatever we do, you find value in it and you can learn something about it, and of course teach us something as well about in terms of whether these courses are useful or not. So yeah, this is kind of just my quick snapshot on models and tools and their value that is being added as we speak. Thank you very much.
Thank you so much, Raghav. And to give you another plug, I know you were involved in a big announcement that came out at COP yesterday of a Global Resilience Index initiative as well. So a lot of this modelling now going global.
Yeah. Now global is becoming the new thing in terms of like how you can scale it up.
Global is the new local.
Yeah, global is the new local, probably.
Thank you. We'll come back to that in a minute. But over then to Carla Cervantes Barron from the University of Cambridge.
Thank you so much. Thank you for having me.
Hello.
Hello. Oh, I'm just dealing with the presentation controls here. Okay, got it. Great. Thank you so much. Thanks for having me. My talk today is going to cover what aspects of supply chain are important in the transition to net zero, including the new or improved materials involved in low carbon systems. I am working with, in the Climate Compatible Growth Program, and I'm based in the University of Cambridge in the Resource Efficiency Collective. This Resource Efficiency Collective is our research group, and we are led by Dr. Jonathan Collin, and we work on several aspects of resource efficiency at different levels. For example, global analysis on energy and materials, or specific topics such as industrial efficiency, transport systems, buildings, and even food and water systems. I've used the term resource efficiency, but I would like to explain it further here. Resource efficiency underpins everything we do in our group. So we ask ourselves this question: can we deliver future energy and material services while reducing resource use and environmental impact? We are able to study specific aspects of resource efficiency by defining systems and identifying metrics, mapping processes, and interlinkages between energy and materials. This use of systems, which actually Vivian and many others have already referred to, is an engineering approach, but we go slightly further by sometimes zooming further out of this classic engineering approach, which can be, for example, production plants. And to do that, to zoom out, we need to understand two things. First, the purpose of the system, which we define then as an output. And second, the energy and material inputs needed for systems to operate, which we refer to as the resource inputs. We can then make representations of these systems, and we tend to use this Sankey diagram, which is shown in the image here, where we use the resource streams that we mapped that flow through the system, and we also use the outputs, where we can identify useful and not useful, so waste and losses, which are outputs to the system. This diagram then lets us visualize the flows and gain valuable insights with which we can make decisions. In our group, one of the Sankey diagrams underpinning a lot of our work is this one, which maps the energy flows globally. We can trace energy from the different sources into conversion stages, which you can see in the middle of the diagram, and then end up with the final services, which are on the right of the diagram, provided by all these energy transformations. The amounts of energy identified in each of the flows have been key to also identify where actions may make the most impact. Other Sankey diagrams in the group are steel, aluminum, petrochemicals, and these have all been helping us make decisions and make recommendations on where actions might be the most needed. Of course, we can also make one of these Sankey diagrams for greenhouse gas emissions, and this is the one I have to show next. This diagram shows the global greenhouse gas emissions, which were mapped in a project we had with the DiCaprio Foundation. And different activities were mapped on the left of this diagram. Then they were traced to economic sectors associated to them. And then devices and energy sources were traced on the right of the diagram to finally obtain the greenhouse gas emissions associated to these energy sources. And if I know it's again going to be hard to look at this diagram, you can go to our website and see it. But we can also see that some sectors may be disaggregated to give us even more information about the system and what needs to change. So mapping greenhouse gas emissions, and especially CO2, as we know, is critical. And it allows this sort of representation allows us to link emissions from industry through to product use, which lets us conclude which flows need to be addressed due to having the highest emissions. For example, as we know, fossil fuels and their burning. Now, if we think of electricity systems, which is one of the other things we are studying, we know that coal is responsible for many emissions, and we know that there are alternatives using renewables to reduce such emissions. There is no doubt about the total emission reductions once we introduce renewables. However, if we take a look at the materials required for building renewables, we can observe that more and more specialized sometimes materials are required to build a power plant that delivers the same amount of energy. And in the diagram I've put here, it's a megawatt hour of electricity that is delivered using either coal or onshore wind. And we see that onshore wind requires more materials. So this example showcases the work we are doing in making sure that the energy transition reaches its maximum low carbon potential. We have concluded that industrial activity needs to be considered and their emissions limited in hand with the introduction of low carbicity. This means that we need to rethink some of our supply chains, make processes efficient, and ensure that supply chains are resilient in the face of both high demand associated to the changing systems and climate change. We have identified two strategies, which are shown here, depending on the country development levels. So the first strategy is we can either replace or retrofit the electricity systems and industry that is used to change those electricity systems, Or we can build low carbon electricity and industry from the start so that the emissions reduced in industry can be then taken to the electricity systems built. So I just want to stress here that it is paramount that low carbon electricity is done in parallel with low carbon industry. Otherwise, we face the risk of locking in industrial emissions. And we know based on current experience how hard it is to decarbonize those locked in emissions. Finally, I want to introduce the model we have created to help us analyze materials required for building electricity systems. We have called it MADDP, which stands for Material Demand Projections. And the key outputs from this model can be divided into three. So we can have trade and industrial implications, which refer to the material requirements that we obtain from each of these systems. Then we can get environmental implications, which can be the embodied emissions related to each of the materials that are required in the system, or the water usage. We can also have socioeconomic implications, such as the costs of the systems or the employment that each of the technologies will generate. So this is a model that is widely applicable, and we have made an example for African countries, which I'm going to show here. We have used this model then to study the materials needed for the projected African electricity system, which in this case is 47 countries. And we have released this as a policy brief, which you can find in the link that I've put below, or you can also navigate via the CCG website. And this study has allowed us to advise which materials are going to have the highest requirements and embodied emissions. And it has allowed us to then propose actions such as increasing industrial efficiency for certain materials or creating material pools, which we are thinking can be similar to electricity pools, and that can help several countries provide the required materials for the energy transition. We think that our model can be used to inform carbon budgets, to inform trade and industrial capacity strategies, to plan infrastructure and create a country development strategy in line with the systems that countries are planning to build. This is it for me. Thank you so much. And I guess we can now go for some questions.
Thank you so much, Carla. Oh, maybe I'll sort of start with one. So this looks like a really brilliant tool and quite different to the one that we saw before, but very complementary. And I wondered if you'd got as far as starting to talk to governments or to financial institutions about how to use this at this point.
Yes, certainly. So I'm actually really excited about this because as part of CCG, we've been engaging with different countries, and we're having the opportunity, of course, to use this tool and expand it for example, in Laos, and we are hoping that many more will use it. And we're looking into building capacity so that countries can take this tool, understand it, add their own data so that the results are really well made and they understand exactly what's happening, and they can then use this to make decisions.
I have so we've had quite a few questions. I think one that's sort of perhaps relevant to you both is so you both talked about the capacity building side of this, and Raghav, you also mentioned that at the end of your talk. And we had one question, which is how do we ensure that decision makers ask the right questions, which I thought was quite an interesting question. But how do we? So, can you talk a bit about that? How do we introduce into a dialogue with governments in particular that maybe aren't thinking about these issues, but are obviously important issues? So how do you get that right balance in the dialogue with a government, for example, about helping them answer the questions that they're asking you, but also helping them ask questions that maybe they haven't thought to ask yet? So what's the right balance there? Maybe you could talk about some of your experiences in that. Carla, if you want to go first as you're on the screen.
Yes. Yeah, so the way we've done it is we introduce our tool and we introduce its capabilities, as well as some of the issues that we already see coming out of this and the experience we've had. And if then any policymaker decides to take it on, we can incorporate their questions, but the tool is almost already built so that it guides us to the right place.
Raghav, how do you get
Yeah.
decision makers to ask the right questions?
Yeah, and I would kind of pretty much agree with things that Carla also said. In our case also, it works with a kind of a show and tell approach because, I mean, there's, first of all, I mean, we are able to talk to stakeholders because they are interested in this question of climate risks and adaptation and everything, but they are always kind of not sure how to approach this, especially at kind of local scales or even kind of understanding, building the national picture. So we kind of go to them with our models and tools and give a demo of what we might have done studies in other countries, or even a quick kind of study done on their countries with open data and stuff. And that's when they react and say like, well, this is what I like about this and this is what I don't like, or these are the kind of scales of impacts that you're predicting which make sense, or this is the ones which do not make sense. So it's a bit of a back and forth in terms of we learn something from them in terms of what we are getting right, and they kind of get also kind of some sort of understanding of whether these tools are useful or not.
I wonder if I could also invite Vivian in. If you're still online, if you could give a thought on that process of engaging with governments, so your clients in particular. How do you, what do you hear from governments in terms of the questions that they're asking, and how do you sort of bring in these potentially newer topics for them in some cases? How do you get that dialogue right with clients?
Well, I think what's particularly challenging about Carla's tool is that it's really looking at the whole life cycle story of the emissions in a sense, right? It's very, very powerful, I think, in that regard. And I think decision makers might be struggle to get them to see where does their responsibility begin and end, right? I think often the decision makers will focus on the actual emissions that are happening on their turf, and they won't worry too much about what happened in manufacturing and upstream. So I think that's a particular challenge of this tool, but one that's definitely worth trying to take on board. I think as we move more towards these carbon border adjustment type of tools, try and make countries aware of the consequences of their decisions in other jurisdictions, I think it will help to bring about a more holistic mindset in looking at these things. But I'm really with this, and I love the Sankey diagrams too. I think they'd be super useful. I don't know if Carla has them for individual countries, but I'd love to see that. Thank you.
Can I ask, certainly today and in other presentations I've seen, often researchers focus either on resilience or on decarbonisation or resource efficiency, in your case, Carla. But I've never really seen a tool that brings it all together into one thing. And I think as the title of this session is on integration, does that exist, and what are the prospects for having some kind of one approach that actually brings all of this together? And I invite you both to say that, or the other speakers, the other panelists as well.
Yeah, I can say something on that, and that's probably, Carla might support me on this because we have started talking to each other more, and we've actually through the CCG program where we are kind of now working on integrating these kind of tools that Carla is developing that talk about, these Sankey diagrams, supply chain, and also there are other tools that talk about more high-level, long-term planning of infrastructures and integrating them with risk, localized risk kind of analytical tools that we are talking about. So this is kind of course, a gap in terms of like lots of long-term planning strategies, tools that you see that do not take into account what happens if you have come up with this interesting energy mix in the future, but there's a massive flood which might just wipe out all your solar power plants or anything. Did you think about it in your modeling? And this is what we are trying to kind of now do and talk to each other in the CCG project that we are now working on.
Yes, that is exactly true. There is so much knowledge that goes into each of these models, and of course, trying to bring them together implies really understanding what their strengths are, but also how those inputs and outputs can feed into each other. And I think I would say again, watch this space in terms of CCG because hopefully we'll be able to offer more as the research goes along. And actually, it also reminded me of how Andrew was also saying the same for transport, and it's a similar thing that we're trying to do here.
Maybe then a link question that I can bring in from the audience, which was around standards. So to start integrating all these approaches, basically we need some kind of common standards that your model speaks the same language as Carla's model and others. Is there any prospect for, or any discussion around how we come up with some standards for these types of analytics that would allow us to start linking these together?
Yeah, I can say something about, I mean, that's where, as Carla says, watch this space within CCG. I can talk about standards in the context of the work that I presented. And there was a reason why I presented a smattering of so many studies across the world, and I was just jumping all around the place, was because we have done all of these continental or national scale or global models with same kind of data and same kind of standardizing data and metrics, because the understanding is that economic impacts is a kind of common metric that applies whether you're looking at a road network or an electricity network or a water network. People want to know what is the asset replacement damage costs, what are the economic costs available, and people want to kind of also know what is the understanding of a network, which is there's some commonality across all these kind of infrastructures because they are all network infrastructure. So we are kind of standardizing our data in that respect across different kind of infrastructures, and that's why we're able to replicate some of these studies and these metrics and provide this information. So there's a lot of kind of things that we do, and when we talk to individual countries and governments about these projects and about our outcomes, we also kind of take data and in a way work with it and standardize it and give it back to them so that there are some principles with which this data needs to be collected and for the future work as well.
Well, perhaps we'll come back to this point, and I'll bring in now our other final two speakers. So now over to Romanus Opiyo. I apologize if I pronounced that incorrectly, from the University of York. Over to you.
Thanks, Nicola. And also let me just start by appreciating the previous presenters for elaborate experience in modeling, which I think I really appreciate, and especially the issue of standards. I hope I'm audible enough.
Yes, go ahead.
Thank you. So my presentation will focus on barriers and opportunities for resilient infrastructure in African cities, and for this particular presentation, we're focusing on two cities. One, Kampala, which is in Uganda, which is in East Africa, and then Lusaka, which is located in Zambia, which is in the southern part of Africa. So in terms of I want to recognize some of the partners. So these are, we have high volume transport HVT, we have Stockholm Environment Institute, you have University of York, you have UNEP, and you have Zambia Road Safety Trust. So in terms of introduction, I'll just appreciate that climate change actually affects mobility, especially of the vulnerable groups, especially women, old persons, the young, and the disabled. They're the mostly affected by this particular climate change in terms of their mobility pattern. And here I just wanted to relate with what Vivian had said about the infrastructure, the asset, the road asset. These are my point of reference in terms of how the asset is affected during harsh climate change. On the right side of the photo, you can see the flooding in Uganda and see how the vehicles are trying to go through. And for instance, if you look at such kind of scenario, you just imagine in terms of someone using a wheelchair, how will they navigate such a situation? So those are the kind of vulnerability we are looking in terms of how they are more exposed. So just in terms of situating the project, so the project is on inclusive climate resilient transport, planning in Africa, funded under the Foreign Commonwealth and Peace, focus on high volume transport HVT, applied research program is related with what Andrew had presented. So project actually is similar in terms of the funding and the focus. So the study focuses on two objectives. So the first one is looking at exploring on how you can incorporate the voices of the disadvantaged groups in transport planning. And secondly, looking at the existing institutional arrangements for climate resilient transport infrastructure in Africa. So in terms of methodology, before I can share this preliminary result, is that we used two methodology in terms of approach to mobility, related to mobility, and secondly, looking out at the institutional arrangements which are existing in this particular in the African cities in terms of how do they embrace the infrastructure resilient, climate resilient. And in the two methodology, one of them was the Delphi survey, which is more of a recursive survey. You use the same results to see whether you can get consensus from the same people who are responding to the questions or the questions read in the Delphi survey. And then secondly, we use the Maptionnaire, which is an online. You can use participants to identify the location of risk areas. So we use those two particular methods just to identify some of the issues. So in this particular case where I'm sharing the preliminary result, where we are looking at how transport system should adapt to climate change. So there was a high level of agreement that the resilience of the transport sector should be given priority in transportation planning. So it's well identified by various transport planners, engineers, and the vulnerable users that they agree that the issue of resilience should be given priority in transportation planning. So in terms of looking at some of the barriers as shared by the various participants in this survey. So one of the barrier which we noticed that there's no central repository for climate data. So in this case, we find that most organizations, they work in silos where different agencies hold data they possess at institutional level. So there's no information sharing. So if my colleagues who have been talking about modeling, so you find when there's no central repository, so you might not know, in fact, which one might be reliable in terms of which to inform your modeling. So this is a challenge in terms of information. Then the second barrier is lack of local data and context relevant solutions, which can inform decisions making with a crucial gap for planning. So this also boils down to the last question where Nicole posed about the standards. So this can be a challenge in terms of how do we get a generic information which can also a local situation where you can be factored in the model. So this lack of local data can become a challenge to most of the models in terms of how to address situation which can be specifically address generic situation. So that's a barrier in terms of how we factor in the climate resilient data. And then the third one is limited opportunities for vulnerable users to voice their concerns. So this leads out to low tapping of local indigenous knowledge. So for example, in a flooding area, they're providing a road infrastructure. And this particular engineer or a professional might not know the highest water point during flooding. So when you bring your infrastructure there, then you might find there it's not factoring this local situation. So indigenous local knowledge is very important in terms of informing the local data. That being the case, so I want just to reflect on some of the opportunities. So one is need for clear, independent, and central climate data center for every agency to access information. So when we avoid this working silos, where different road agencies and stakeholders can share information, then we are also going to address this problem where we are planning without climate data, climate resilient data. Then the second point is consideration for vulnerable users to voice their concerns and share the knowledge. This is very important in terms of uptake of the local indigenous knowledge when you are doing any modeling or when you are now developing an asset, a road asset. The third one is climate data interpretation and training is critical to guide climate resilient transport so that the local situation, the local engineers, they are able to use that information to plan well to respond to the growing issues, especially on climate. So in conclusion, there are 4 points, but I'll just which are related is just to appreciate that climate data by both formal and informal process in planning and designing transport infrastructure. And this also, I think, was alluded by Vivian when he was talking about the interaction of the formal and informal planning. So climate data will be important for those particular aspects. The second issue is addressing climate resilience can contribute to social inclusion among vulnerable transport users. So when they voice out, then the inclusion, which is very important. So in terms of looking at the methods, I've just appreciate that the electric survey method and Maptioneer are complementary tool that can be useful to determine stakeholder consensus on key priority issues, identify areas of greatest climate risk, especially because the Delphi will look at the consensus, and then the Maptioneer look at the risk in terms of spatial where they're located. So these are very important tool in terms of trying to appreciate the consensus aspect and the specificity brought out by the Maptioneer. And then lastly, is that lack of or inadequate climate data is a major barrier in delivery of climate resilient transport infrastructure in Africa. And that, I think, has been witnessed by the previous presenters. So what I want to share with you. Thank you very much for your attention.
Thank you very much, Romanus. I think you've raised some really critical points there, which some link well to some of the questions we've had, but also some of Andrew's points, I think, from the second presentation. So two key takeaways for me were, one is about the sort of process and having an inclusive process to make sure all voices are heard, which I think links back to some of Andrew's comments very well. But then also one which links into one of the questions we've had, which is about sort of more on the data side, sort of getting the right key performance metrics or the right metrics to the right types of audiences, and what the things that are important to the most vulnerable communities, the people that are actually using the infrastructure, a very different set of metrics to the ones that, say, a Ministry of Finance will want to see, or a Ministry of the various infrastructure line ministries. So I think there's a point there for Raghav and and Carla about also getting, how we get the right metrics that maybe we can come back to in the discussion. But now I want to go across to Ken from MIT, if you're still on the line. You've been very patient as our last speaker. Over to you.
Great. Thank you very much, Nicola, and my fellow panelists. I think I come at the appropriate time. Waiting is good because my work will synthesize a lot of what has been said before. And what I'm going to talk about today is a little anticlimactic. It's not a launch of the Africa Climate Resilient Investment Facility. This is more a trailer, like in a movie, telling you what's going to come soon in 2022. And so we're going to share what's going on and what we're hoping to do as we develop two of the components, the guidance notes and the training. what we want to say, and it's really exciting that we have Vivian on the panel, but the way the African Climate Resilience Facility came about was in 2010, two World Bank activities came together separately. One was the Africa Infrastructure Climate Diagnostic, where Vivian and her team came up with the amount that about $93 billion a year was needed to bring Africa's infrastructure up to what it should be. And then at the same time, there was the economic of adaptation to climate change study done by the World Bank, which said globally we needed about 100 billion in adaptation funds for infrastructure. So those two things came together to a project which was to look at Africa-specific, enhancing the climate resilience of Africa's infrastructure. So bringing those two things together, the ECRI project came out of that. And as a result of the ECRI project, funded by a number of different trust funds, there was the African Climate Resilient Infrastructure, which was funded by the Nordic Development Fund and includes the African Union, the Economic Commission for Africa, and the World Bank. Next slide. And so this Africa facility has 4 components. One is project level technical assistance for bringing resilience into ongoing infrastructure projects, and outreach, dissemination, and training, guidelines and standards, and then climate knowledge and a data portal. And you see who are taking the leads of those. And our team that involved with a team of experts from around the world, including Mark Howells, who's involved with our session today, is out there and looking at this audience, what they're trying to do with this program, and is to look at government ministries to get them informed about the issues related to this, and then start developing local practitioners. And we heard that before. How do we get this into interaction is by getting the local consultants, the local academics, and others to get access to the tools, to make those tools appropriate for local decisions, and then also working with donors and development banks to bring the aspects of resilience into project development. And so there's been a lot of tools that are going on, and in particularly in developing these that's being led by the World Bank, which will become documents for the training as well. The goal is to take these guidance, to allow that to help people understand what is the appropriate levels and types of analysis that are needed, things like we're hearing today, and how to bring them into best practice. And looking at these best practices in the different tools that are there and the issues we talked about is very crucial in getting access to the climate data that's needed. All of these things are part of that. And the guidance documents, which will be on the order of 30 to 40 pages, are designed to be a roadmap on how to go forward. And one of the key things that is in part of these guidance documents is there to be integrative and not to be just looking at technology, but also bringing insights into how we're going to finance and implement these projects, and how does that come into the adaptation and the resilience that we build in. So one of the ideas of this is coming up with a climate resilient investment framework, and it wants to be integrative, to draw on some of the other products that are out there, but to take someone in their project, if they're coming in a project that's in the middle or they're starting at the end, you come into this diagram, where are you in this process, and how can you bring climate resilience into it? Because some projects are way down the road where they've already done most of their planning or even design. Can we come in there? Or if we're starting at the beginning, how do we take climate resilience in there? So looking at that across the number of ways, and we're looking at 6 sectors as we look at the infrastructure. And these 6 sectors include energy, water, transport, cities, ecosystems, and agriculture. And each guidance notes will modify this approach appropriately for that sector. But one of the key things that is out of that, and we heard this later by our speakers before, is what is the appropriate tools to use for the type of decision you're making. So one of the key parts about this is deciding how critical the project is, and then what is its useful life, and then fitting that into the different types of analyses, the data and the models that need to be applied, because not all tools that we have should be applied everywhere. But to use a good term, horses for courses. What should we do? And if you have a very short project, you're looking more at climate variability now. If it's a long-term, like a reservoir, you're looking at both climate variability and climate change in the context of growth in the future. So how we deal with those things in the document is one of the things that we're trying to get across through this work. These documents or guidance notes will be available standalone and for each of the sectors, as well eventually in a bound volume with all of them together, and will be available. Then these documents, because the facility is cooperation between the World Bank and the UN system of ECA, they will be the background for a training program. And there's a training program that is designed to provide training at two levels. One is large level focus for decision makers, and others on making them aware of the issues of climate resilience in infrastructure planning, and also, as was brought out importantly, how do we link the ministries of finance and the people dealing with budgets and finance with the issues of climate variability, and how can the sectoral infrastructure people understand the way in the metrics that are needed by them. And so understanding climate resilience, and then also strengthening that technical expertise so we can actually do the analysis. So the program for capacity building, and very interesting, like we saw the open course, and we'll be talking more about that, is it's an actual program that will be offered through UNECA's Institute for Development and Education out of Senegal, and it will have three components: a training capacity package 1, which will bring knowledge about what's out there in climate modeling and what is the issues of climate resilience, and that's focused for the more general audience. And then there are going to be specific sector areas for the 6 we mentioned, water to cities, etc. And there will be certificates given when people are trained in this area, so we can start certifying that people have the expertise that they need. But then finally, everyone going through this program is going to learn about communicating risk, and also how do we bring financing into these projects. So if you're going to be trained, you have to go through these 3 different work packages and training packages. And then when you'll come out, we're working now with a few different universities to potentially give graduate credit if they take this course and do some work associated with it. As was already mentioned, and we can bring out the whole idea of open source and getting tools available in the hands is going to be part of the training package. And so this is just an example in those 6 areas of open source models. For example, in the energy area, the osmosis model, we will be training, making people aware of the power of these tools and how they can be used for this, but also it'll be available because we will be presenting them with links, and there'll be a clearinghouse on people can get these models and training for them, as well as they'll be doing case studies with them when they focus on these different sectors. But in transport and in other areas, well documented and used tools will be out there. And then finally, this is all going to be coming together in the next year. And the training program is targeting 100 practitioners to be trained through the program by the end of 2022, and that 300 people will attend webinars on the overall training package 1 and 3 to get the overall issue of what's going on. So we're really excited to be involved in that, and you'll be hearing more, and we'll have pamphlets to hand out at further times. But the whole point of this also is its focus for Africa. There are a number of issues related to Africa specific, and that's what this is targeted on. And we're standing on the shoulders of giants. We have a group of experts from around the world and from Africa working together to make this practical, local, and to make a difference. So thank you.
Thank you so much, Ken. So I think we're down to our sort of last couple of minutes, and I've got a question for you, and then I'm going to give a line to Vivian to sort of close us off as well. So for you, Ken, so one of the questions that we've been asked by the audience is how do we build demand for the types of tools and information that we've been talking about today? And will the program that you've talked about have, how will you build demand for this program, but also this type of knowledge and tools that you've talked about in your presentation?
Okay, I think there's a couple different things, but I think the demand is there because as I'm just reading what's coming out of COP, most of the donors and development agencies are requiring resilience and all new infrastructure projects. The bank is, etc. And that demand is being filled by consultants from the North and international experts. And I do that too much. And we're finding out that our models don't understand local conditions well, as Ramios pointed out very well. What is critical in Lusaka may not be critical in Kampala or critical in Cairo. So we need to have local people using these tools jointly with sometimes international experts, but local academics as well. So it's all about empowering locals to use these tools for them to make these difficult climate resilience issues, because as one of the things we work on in other work is linking the macro with the micro. And the macro is looking at, we don't have enough budgets to do this. What are the key things and how can we do this? And do we spend money now for future generations? Where does it make sense? So those are local decisions, and that's the whole point. So I think the demand is there now, and as it goes out, it will, I think, will hopefully meet that.
Thank you so much, Ken. And maybe then to you, Vivian, for a final word. So what do you see next, particularly for this community that we've been talking about today? What would you like to see, and what are the exciting things on the horizon for you?
Well, thanks, Nicola. I've been fascinated listening to these presentations because we've really been hearing a tale of two worlds, in a sense. I think from Andrew and Roman, we got a sort of ground level view, which was quite sobering. They said there's very little resilience planning going into transport systems. The countries don't have the capacity. The data is lousy. It's kind of a gloomy view from the ground up. Then, I think from Carla, we got this much more upbeat kind of global view. We've got the tools, we've got the global data sets, we can do these really cool things. And I think Ken's presentation in a way was trying to make a bridge between those two worlds. I mean, clearly the global tools are powerful, but in order for them to really have the impact on the ground, there has to be the ownership, the understanding, the customization, which does call probably for more ground truthing of the data. I think there's a very nice kind of arc through this whole session, and it really underscores the importance of the capacity building work that Ken and others are doing to try and bring these two worlds together. Thanks, Nick.
Thank you so much, Vivian. And thank you to all of our speakers. We're really, really grateful. Brilliant talks and all fitted together perfectly, as you said, as a perfect sort of arc of activities, and looking forward to seeing what comes next from each of you. And thank you very much to our audience in the room and online. Thank you for the excellent questions. And we'll close there. Thank you so much. Goodbye.